Good day, ma'am. Today, we will be discussing about domestic wastewater treatment. Before we go to the treatment process, we must first understand what is a domestic wastewater. Domestic wastewater is the water coming from every household of a community, containing everything, not only the water itself, but also the substances and materials added during the usage of water. These substances and materials may include human waste, laundry waste, kitchen waste, personal hygiene waste, or anything and everything that is added to the water during its usage. It is said that a fresh aerobic domestic wastewater has been said to have the odor of a kerosene or a freshly aged earth. On the other hand, aged sewage domestic wastewater is considered to be more offensive on the olfactory nerves. A fresh domestic wastewater has a gray color while septic sewage has a black color. Wastewater temperature normally range between 10 to 20 degrees Celsius. The temperature of the wastewater will be higher than that of the water supply. This is because of the addition of warm water from household heating within plumbing system of the structure. 1 cubic meter of wastewater weighs approximately 1 million grams. It will contain about 500 grams of solids. One half of the solids will be dissolved solids such as calcium, sodium, and soluble organic compounds. The remaining 250 grams will be insoluble. It is also said that a domestic wastewater contains different chemicals. For example, phosphorus may appear in many forms in wastewater. Among the forms found are the orthophosphates, polyphosphates, and organic phosphates. Lump all of these together under the heading total phosphorus. In this table, we can see the typical composition of untreated domestic wastewater. Its constituents include alkalinity, BOD, 5, chloride, COD, suspended solids, sitiable solids, total dissolved solids, total nitrogen, total organic carbon, and total phosphorus. It can be categorized into weak, medium, and strong, and has a corresponding mg per L units and has a corresponding number of units. We will now go to the treatment process. The first process is the preliminary treatment. Preliminary treatment. In preliminary treatment, its main purpose is to remove materials that can cause operational problems. The first part is the bar rocks. The primary purpose of the rock is to remove large objects that would damage or foul pumps, valves, and other mechanical equipments. The solid material is stored in a hopper and removed to a sanitary landfill at a regular interval. And these bar rocks can be mechanically or manually cleaned. The second part is the grate chambers. It removes inert dense material called grit, such as sand, broken glass, silt, and pebbles. It avoids abrasion of pumps and other mechanical devices. There are two basic types of grit chambers. It can be aerated or vortex. An aerated grit chamber its performance is a function of the roll velocity and detention time. The roll velocity is controlled by adjusting the air feed rate. Grit accumulation in the chamber varies greatly, depending on whether the sewer system is a combined type or a separate type and on the efficiency of the chamber. As you can see in the slide, that it has a picture of an aerated grate chamber. The second type of grate chamber is the vortex grate chamber. Wastewater is brought into chamber tangentially. At the center of the chamber, a rotating turbine with adjustable pitch blade along with the cone-shaped floor produces a spiraling donut-shaped flow pattern. This pattern tends to lift the lighter organic particles and settle the grit into a grit sump. The effluent outlet has twice the width of the influent flume. This results in a lower exit velocity than the influent velocity and thus preventing grit from being drawn into the effluent flow. The third part of the preliminary treatment is the equalization basins. Its main purpose is to dampen the variation in the wastewater flow into a wastewater treatment plant. It improves effectiveness of primary and secondary treatment, usually achieved by large basins to collect wastewater and pump to a treatment plant at a constant rate. The second part of the treatment process is the primary treatment. It is the second step of the wastewater treatment. It allows for physical separation of solids and grease from the wastewater. The screened wastewater flows into a primarily settling tank where it is held for several hours, allowing solid particles to settle to the bottom of the tank and oils and greases to flow to the top. Primary treatment separates suspended solids and greases from wastewater. Wastewater is held in a tank for several hours allowing the particles to settle to the bottom and the greases to flow to the top. Settling or sedimentation. Solid-liquid separation process in which the suspension is separated into two phases. In this part, ang solid liquid it is a process that separates the suspension into two phases. It can either be clarified supernatant leaving the top of the sedimentation tank or the overflow, or the concentrated sludge leaving the bottom of the sedimentation tank or the underflow. The purpose of settling is to remove coarse dispersed phase, to remove coagulant and flocculated impurities, to remove precipitated impurities after chemical treatment, and to settle the sludge after activated sludge process after this the trickling filters. This is an example of a primary settling tank. Primary settling tank design example. Its size is 3 to 24 meters wide and 15 to 100 meters long if it is rectangular, and if it is circular, its diameter ranges from 3 to 90 meters. Its detention time is 1.5 to 2.5 hours and having an overflow rate of 25 to 60 m³ per m² of day. Typical removal efficiencies in solids it is 50 to 60% and in BLE5 it is 30 to 35%. Example, a rectangular primary clarifier having 2.4 meters deep and 4 meters wide is designed to settle a flow of 2000 m³ per day and have an overflow rate of 32 m³ per m² per day. Question, how long should it be and what detention time will it have? In finding its length, we know that the formula of overflow rate is equal to flow rate over area. We'll just plug in the data and we can see that in the section of area, we don't know what is length. We only have its width but not its length. So rearranging the data, we can come up in an equation that length is equal to flow rate over width times overflow rate, which is 15.6 meters. In detention time, we know that detention time is equal to volume over flow rate. Just plug in a given data and we can come up to an answer of 1.8 hours. That is the detention time of the given example. The third part of the treatment process is the secondary treatment. Secondary treatment is a biological treatment process that removes dissolved organic matters from wastewater. Sewage microorganisms are cultivated and added to the wastewater. The microorganisms use organic matter from sewage as their food supply. This process leads to decomposition or biodegradation of organic waste. The most basic approach in secondary treatment is to use aerobic biological degradation. Its objective is to allow the BOD to be exerted in the treatment plant rather than the stream. We can see its chemical equation here. How to accomplish aerobic biological degradation? Aerobic biological degradation creates a very rich environment for growth of a diverse microbial community. Its basic ingredients include high density of microorganisms. It keeps organisms in system. Good contact between organisms and waste. It provides mixing. Provides high levels of oxygen during aeration. Favorable temperature, pH, and nutrients. Design and operation. No toxic chemicals present. Two types. There are two types of aerobic biological degradation. The first one is dispersed growth, or can say suspended, and the second one is the fixed growth or attached. In dispersed growth includes activated sludge and oxidation ditches or ponds, and in fixed growth includes trickling filters, rotating biological contactors. Activated sludge, process in which a mixture of wastewater and microorganisms is agitated and aerated, leads to oxidation of dissolved organics. After oxidation, separates sludge from wastewater. Induced microbial growth need food, oxygen, want mixed liquor system or MLS of 3,000 to 6,000 mg per L. This is the activated sludge process. From raw wastewater to mixed liquor and aerated to secondary clarifier, so on. Activated sludge design. Detention time is approximately 6 to 8 hours. Long aeration basins. Air is injected near bottom of aeration tanks through a system of diffusers. Aeration system used to provide mixing. The second type of dispersed growth is the oxidation pans. An oxidation pan is a pan that receives partially treated wastewater, Waste stabilization pans has been used as an all-inclusive term that refers to a pan or lagoon used to treat organic waste by biological and physical processes. Its classification include aerobic pans. First one is aerobic pans. Shallow pans less than 1 meter deep, where dissolved oxygen is maintained throughout the entire depth, mainly by the action of photosynthesis. In this type of pan, the dissolved oxygen is maintained through the process of photosynthesis. The second classification is the facultative pans. Pans 1 to 2.5 meters deep, which have an anaerobic lower zone, a facultative middle zone, and anaerobic upper zone, maintained by photosynthesis, and surface aeration. In this classification, a pond has three zones: the lower zone, which is anaerobic, the middle zone, which is a facultative, and the upper zone, which is aerobic, and it is maintained by photosynthesis and surface aeration. The third classification is the anaerobic ponds. Deep ponds that receive high organic loadings such that anaerobic conditions prevail throughout the entire pond depth. In this classification of pond, it is very deep and it receives high organic loadings such that ang anaerobic conditions prevail throughout the entire pond depth. The fourth classification is the maturation or tertiary ponds. Ponds used for polishing effluents from other biological processes. Dissolved oxygen is furnished through photosynthesis and surface aeration. This type of pond is also known as polishing pond. The fifth classification is the aerated lagoons. Ponds oxygenated through the action of surface or diffused air aeration. On the other hand, in the second type, which is the fixed growth, its type include trickling filters, consist of a bed of coarse materials such as stones, slats, or plastic materials over which wastewater is applied. The most widely used design for many years was simply a bed of stones from 1 to 3 meters deep through which the waste passed. These stones provide large amounts of surface area where microorganisms cling and grow in a slime on the rocks as they feed on the organic matter. Because the microorganisms that biodegrade the waste form a film on the media, this process is known as an attached growth process. May siyang forma sa trickling filter plant with enlargement of trickling filter. This is how it is look like. In a simpler term, these stones are used as kanang murag breedinganan sa mga microorganisms na dala sila managhan or mopilit or unsa ba. The second type is the rotating biological contactors or RBCs. The RBC process consists of a series of closely spaced discs 3 to 3.5 meters in diameter, mounted on a horizontal shaft and rotated while about one half of other surface area is immersed in wastewater. The discs are typically constructed of lightweight plastics. The speed of rotation of the disc is adjustable. When the process is placed in operation, the microbes in the wastewater begin to adhere to the rotating surfaces and grow there until the entire surface area of the disc is covered within 1 to 3 millimeters layer of biological slime. Mao ni siya ang forma sa katong mag-disc mo tuyok. Purpose of the disc: they provide media for the buildup of attached microbial growth. They bring the growth into contact with the wastewater. They aerate the wastewater and the suspended microbial growth in the reservoir. In simpler term, RBCs has naay tuyok nya dito mapilit ang mga microorganisms and dito na sila mo mga siya ang mag-serve nga breeding place nila dito sila managgan mamilit. Ito. The fourth treatment process is the tertiary treatment. The need for treatment of wastewater beyond that which can normally be accomplished in secondary treatment is based on the recognition of one or more of the following. Increasing population pressure result in increasing loads of organic matter and suspended solids to rivers, streams, and lakes. The need to increase the removal of suspended solids to provide more efficient disinfection. Third, the need to remove nutrients to limit eutrophication of sensitive water bodies. Fourth, the need to remove constituents that preclude or inhibit water reclamation. Tertiary treatment processes include first, granular filtration, second, membrane filtration, third, carbon absorption, fourth, chemical phosphorus removal, fifth, biological phosphorus removal, and sixth, nitrogen control. The first process is the granular filtration. By using a filtration process similar that used in wastewater treatment plants, it is possible to remove residual suspended solids, including the unsettled microorganisms. Filtration can achieve 80% suspended solids reduction for activated sludge effluent and 70% reduction for thickly filtered effluent. Simpler term, ang granular filtration, gina-filter niya itong mga solids kanang mga dagko-dagko nga solids na ma-filter pa. The second process is the membrane filtration. One most commonly used in tertiary treatment is microfiltration. It is used as replacement for granular filtration. Microfiltration processes have achieved BOD removal of 75 to 90% and total suspended solids removal of 95 to 98%. The third process of a tertiary treatment is carbon adsorption. The most practical available method for removing refractory organics is by adding adsorbing them and activated carbon. Adsorption is the accumulation of materials at an interface. The interface in the case of wastewater and activated carbon is the liquid/solid boundary layer. The activation process results in the formation of many pores within each carbon particles. The vast areas of the walls within these pores account for the total surface area of the carbon, which makes it so effective in removing organics. In carbon absorption, its main purpose is to remove organics. Chemical phosphorus removal. The removal of phosphorus by chemical precipitation is accomplished by using one of the three compounds. The precipitation reaction for each are shown below. So, kailangan jud i-remove ang phosphorus kay delikado siya. And these three compounds are used: ferric chloride, alum, and lime. And the precipitation reactions of these three ngani ang porma. Example, if wastewater has a soluble orthophosphate concentration of a 4 mg per liter as P, what theoretical amount of ferric chloride will be required to remove it completely? We see that 1 mole of ferric sa katong nakita ay sa atong katong precipitation reaction, we can see that 1 mole of ferric chloride is required for each mole of phosphorus to be removed. The pertinent gram molecular weight are as follows. Ang FeCl3 is 162.2 grams and phosphorus kay 3.97 grams. With PO4 minus PO4 mg per L, the theoretical amount of ferric chloride would be 4 times 162.2 over 30.97 is equal to 20.25 mg per L. The fifth process is the biological phosphorus removal. In biological phosphorus removal, or BPR, or you can say BioP, or enhanced biological phosphorus removal, as it is sometimes called, the phosphorus in the wastewater is incorporated into cell mass in excess of levels needed for cell synthesis and maintenance. This is accomplished by moving the biomass from an aerobic to anaerobic environment. The phosphorus contained in the biomass is removed from the process as biological sludge. BioP removal is not used in systems that are designed for nitrification without providing a means of denitrification. Bawal ang BioP kung ang system nimo kay naay nitrification pero walay means o pamaagi kung unsaon pag denitrificate. The sixth process is the nitrogen control. Nitrogen in any soluble form is a nutrient and may need to be removed from wastewater to help control algal growth in the receiving body. So, ang nitrogen daw kay nutrient man daw siya, so pwede siya maka-help sa pagtubo sa mga algae na ito sa receiving body. So kailangan jud siya i-remove. In addition, nitrogen in the form of ammonia exerts an oxygen demand and can be toxic to fish. Removal of nitrogen can be accomplished either biologically or chemically. The biological process are called nitrification or denitrification or sometimes biological nitrogen removal. The chemical process is ammonia stripping. Nitrification or denitrification. The natural nitrification process can be forced to occur in the activated sludge system by maintaining a cell detention time of 15 days in moderate climates and over 20 days in cold climates. The nitrification step is expressed in chemical terms as follows. Ammonia stripping. Ano kailangan mag ammonia stripping? Kaya ang as what said before other slides, ang ammonia kay may cause or ammonia exerts oxygen demand and can be toxic to fish. Nitrogen in the form of ammonia can be removed chemically from water by raising the pH to convert the ammonium ion to ammonia, which can then be stripped from the water by passing large quantities of air through the water. Sa ammonia stripping, ang first step niya kay ipataas ang pH para ma-convert ang ammonium ion into ammonia. Then, ang kanang ammonia, pwede siya kwaon or strip siya sa water by passing large quantities of air through the water. The process has no effect on nitrate, so the activated sludge process must be operated at a short cell detention time to prevent nitrification. The ammonia stripping reaction is NH4 positive plus OH negative yields NH3 plus water. The fifth process of domestic wastewater treatment is the solid processing and its sludge treatment. In the process of purifying the wastewater, another problem is created, sludge. After all the processes in domestic wastewater, mahuman nanapoy bago nga problema nga mabot ang mao ni ang sludge. The higher the degree of wastewater treatment, the larger the residue of sludge that must be handled. The sludge is made of materials settled from the raw wastewater and of solids generated in the wastewater treatment processes. The quantities of sludge involved are significant. For primary treatment, they may be 0.25 to 0.35% by volume of wastewater treated. The activated sludge process increases the volume to 1.5 to 2%. Use of chemicals for phosphorus removal can add another 1%. Basic processes for sludge treatment. First, thickening. Separating as much water as possible by gravity or flotation. Stabilization. Converting the organic solids to more refractory forms so that they can be handled or used as soil conditioners without causing a nuisance or health hazard. This biochemical oxidation processes are called digestion. Third, conditioning. Treating the sludge with chemicals or heat so that the water can be readily separated. Painitan ito. Dewatering. Separating water by subjecting the sludge to a vacuum, pressure, or drying. Fifth, reduction. Converting the solids to stable form by wet oxidation or incineration. These are chemical oxidation processes. They decrease the volume of sludge, hence the term reduction. So, mao ni siya ang basic sludge handling alternatives. Sources and characteristics of various sludges. First, grit. The sand, broken glass, nuts, bolts, and other dense materials that is collected in the gate chamber is not true sludge in the sense that it's not fluid. However, it still requires disposal because grit can be drained of water easily and is relatively stable in terms of biological activity if it is not biodegradable. It is generally trucked directly to a landfill without further treatment. So, kailangan jud i-dispose ang mga grit o i-deliver sa mga landfills. Second characteristic of our sludge is primary or raw sludge. Large sludge from the bottom of the primary clarifier contains from 3 to 8% solids. The solid fraction is approximately 70% organic. This sludge rapidly becomes anaerobic and is highly odoriferous. Secondary sludge. This sludge consists of microorganisms and inert materials that have been wasted from the secondary treatment plants. Wasted activated sludge is typically 0.5 to 2% solids, while trickling filter sludge contains 2 to 5% solids. In some cases, secondary sludges contain large quantities of chemical precipitates because the aeration tank is used as the reaction basin for the addition of chemicals to remove phosphorus. Tertiary sludges. The characteristics of sludge from tertiary treatment processes depend on the nature of the process. For example, phosphorus removal results in a chemical sludge that is difficult to handle and treat. When phosphorus removal occurs in the activated sludge process, the chemical sludge is combined with biological sludge, making the latter more difficult to treat. Kung ang phosphorus removal daw mo occur sa activated sludge process, ang chemical daw mo combine sa biological sludge niya. Mo to lisod na siya ay treat. Nitrogen removal by denitrification results in a biological sludge with properties very similar to those of waste activation sludge. And that's all. That's all. Thank you.